Bash Introduction. In this video, we are going to see about Bash Introduction. Bash is the Unix shell and command language written by Brian Fox for the GNU project as a free software replacement for the Bourne shell. First released in 1989, it has been distributed widely as it is a default shell on the major Linux distribution and OS X. Bash is available primarily shell for GNU or Linux and Mac OS X. Bash is available for Solaris and the various BSD systems and can be easily compiled for just about any other Unix system. Bash heritage and features. In this video, we are going to see about Bash heritage and features. Although the Bourne shell is still known as a standard shell, Bash is becoming increasingly popular. In addition to its Bourne shell compatibility, it includes the best features of the C and Korn shells as well as several advantages of its own. Bash's command line editing modes are the features that tend to attract people to it first. With command line editing, it's much easier to go back and fix mistakes or modify previous commands than it is with the C shell's history mechanism. The other major Bash features that is intended mostly for interactive users is job control. Job control gives you the ability to stop, start, and pause any number of commands at the same time. This feature was borrowed almost verbatim from the C shell. The rest of Bash's important advantages are meant mainly for shell customizers and programmers. It has many new options and variables for customization, and its programming features have been significantly expanded to include function definition, more control structures, integer arithmetic, advanced input or output control, and more. The Bash shell provides the following features: input or output redirection, wildcard characters for file name abbreviation, shell variables and options for customizing the environment, a built-in command set for writing shell programs, shell functions for modularizing tasks within a shell program, job control, command line editing, that is using the command syntax of either VI or Emacs, access to previous commands, that is command history, integer arithmetic, arrays and arithmetic expressions, command name abbreviation, that is aliasing, upwards compliance with POSIX, internationalization facilities, and arithmetic for loop. Command line shortcuts. In this video, we are going to see about command line shortcuts. If ever there were an installment of Linux Explorers to print out and tack up on the wall beside your Linux machine, it's this one. Linux is now here near to escaping its Unix roots, and many Linux users feel that's a good thing. This week, we will tackle the Linux console and the many commands you use in it. Windows users who date back to the DOS days will find all this strangely familiar, since many DOS commands typed at the C prompt bear more than a passing resemblance to their Unix or Linux counterparts. On the other hand, this can also be deceiving. DOS and Linux are very different. The console or terminal. You will find your console or terminal somewhere on the main menu of your desktop graphical user interface. When you open it, you will be presented with a text prompt that will end with $symbol. That means you are logged in as a normal user. After typing the su command and providing your password, the $symbol prompt will change to a hash prompt, indicating that you are logged in as root. Su. Ctrl D logs you out as root and brings back the $prompt. And if you use the Ctrl D keyboard combination again, the console will close. A normal prompt looks something like. For nearly every program or command, there are man-UL pages stored on your computer. Man pages are built-in Linux documentation files. You can read them by typing this in the console. Man. Here's a specific example. The following command elects the main pages for the cp command, that is, which handles file copies. Man cp. Use the space bar to scroll the page and press the Q key to close the man pages. More information on individual console commands can often be found by typing help or info after any command like this. Navigating the file system and simple commands. These are the most often used navigational or directory-related Linux console or terminal commands. History tricks. In this video, we are going to see about history tricks. We use history command frequently in our daily routine jobs to check history of command or to get info about command executed by user. In this post, we will see how we can use history command effectively to extract the command which was executed by users in Bash shell. This may be useful for audit purpose or to find out what command is executed at what date and time. By default, date and time stamp won't be seen while executing history command. However, Bash shell provides CLI tools for editing users' command history. Let's see some handy tips and tricks and power of history command. List last or all executed commands in Linux. Executing simple history command from terminal will show you a complete list of last executed commands with line numbers. List all commands with date and time stamp. How to find date and time stamp against command. With export command with variable will display history command with corresponding time stamp when the command was executed. Filter commands in history. As we can see, same command is being repeated number of times in above output. How to filter simple or non-destructive commands in history. Use the following export command by specifying command in histignore is equal to is I pwd date will not saved by system and not be showed in history command. Unset export command. Unset export command on the fly. Execute unset export command with variable one by one whatever commands have been exported by export command. Save export command permanently. Make an entry as follows in .bash profile to save export command permanently. Disable storing history of commands. Some organizations do not keep history of commands because of security policy of the organization. In this case, we can edit .bash profile file of users and make an entry as below. Delete or clear history of commands. With up and down arrow, we can see previously used command which may be helpful or may irate you. Deleting or clearing all the entries from bash history list with C options. Search commands in history using grep command. Search command through bash history by piping your history file into grep as below. The below command will search and find pwd command from the history list. Search lastly executed command. Search previously executed command with Ctrl+R command. Once you have find the command you are looking for, press enter to execute the same, else press escape to cancel it. Recall lastly executed command. Recall a previously used specific command. Combination of bang and 8, that is not 8 command, will recall number 8 command which you have executed. Expansion. In this video, we are going to see about expansion. Each time you type a command line and press the enter key, bash performs several processes upon the text before it carries out your command. We have seen a couple of cases of how a simple character sequence, for example, can have a lot of meaning to the shell. The process that makes this happen is called expansion. With expansion, you type something and it is expanded into something else before the shell acts upon it. To demonstrate what we mean by this, let's take a look at the echo command. Echo is a shell built-in that performs a very simple task. It prints out its text arguments on standard output. That's pretty straightforward. Any argument passed to echo gets displayed. Let's try another example. So what just happened? Why didn't echo print? As you recall from our work with wildcards, the asterisk character means match any characters in a file name. But what we didn't see in our original discussion was how the shell does that. The simple answer is that the shell expands the asterisk into something else. That is, in this instance, the names of the files in the current working directory before the echo command is executed. When the enter key is pressed, The shell automatically expands any qualifying characters on the command line before the command is carried out. So the echo command never saw the asterisk, only its expanded result. Knowing this, we can see that echo behaved as expected. Path name expansion. The mechanism by which wildcards work is called path name expansion. If we try some of the techniques that we employed in our earlier lessons, we will see that they are really expansions. Given a home directory that looks like this, we could carry out the following expansions, and or even and looking beyond our home directory. Tiled expansion. As you may recall from our introduction to the cd command, the tiled character has a special meaning. When used at the beginning of a word, it expands into the name of the home directory of the named user, or if no user is named, the home directory of the current user. If user 4 has an account, then arithmetic expansion. The shell allows arithmetic to be performed by expansion. This allows us to use the shell prompt as a calculator. Arithmetic expansion uses the form where expression is an arithmetic expression consisting of values and arithmetic operators. Arithmetic expansion only supports integers, that is whole numbers, no decimals, but can perform quite a number of different operations. Spaces are not significant in arithmetic expressions, and expressions may be nested. For example, to multiply 5 squared by 3, single parenthesis may be used to group multiple sub-expressions. With this technique, we can rewrite the example above and get the same result using a single expansion instead of two. Here is an example using the division and remainder operators. Notice the effect of integer division. Brace expansion. Perhaps the strangest expansion is called brace expansion. With it, you can create multiple text strings from a pattern containing braces. Here's an example. Patterns to be brace expanded may contain a leading portion called a preamble and a trailing portion called a postscript. The brace expression itself may contain either a comma-separated list of strings or a range of integers or single characters. The pattern may not contain embedded white space. Here is an example using a range of integers. A range of letters in reverse order. Brace expansions may be nested. The most common application is to make a list of files or directories to be created. For example, if you were a photographer and had a large collection of images you wanted to organize into years and months, the first thing you might do is create a series of directories named in numeric year-month format. This way, the directory names will sort in chronological order. You could type out a complete list of directories, but that's a lot of work and it's error-prone too. Instead, you could do this. Parameter expansion. It's a feature that is more useful in shell scripts than directly on the command line. Many of its capabilities have to do with the system's ability to store small chunk of data and to give each chunk a name. Many such chunks, more properly called variables, are available for your examination. For example, the variable named user contains your username. To invoke parameter expansion and reveal the contents of user, you would do this. To see a list of available variables, try this. You may have noticed that with other types of expansion, if you mistype a pattern, the expansion will not take place and the echo command will simply display the mistyped pattern. With parameter expansion, if you misspell the name of a variable, the expansion will still take place but will result in an empty string. Command substitution. Command substitution allows us to use the output of a command as an expansion. Here, we passed the result of which CP as an argument to the ls command, thereby getting the listing of the CP program without having to know its full path name. There is an alternate syntax for command substitution in older shell programs, which is also supported in Bash. It uses back quotes instead of the $ and parentheses. Quoting. In this video, we are going to see about quoting. Now that we have seen how many ways the shell can perform expansions, it's time to learn how we can control it. Take for example, in the first example, word splitting by the shell removed extra white space from the echo command's list of arguments. The shell provides a mechanism called quoting to selectively suppress unwanted expansions. Double quotes. The first type of quoting we will look at is double quotes. If you place text inside double quotes, all the special characters used by the shell lose their special meaning and are treated as ordinary characters. The exceptions are $, slash, backslash, and backquote. This means that word splitting, path name expansion, tilde expansion, and brace expansion are suppressed, but parameter expansion, arithmetic expansion, and command substitution are still carried out. Using double quotes, we can cope with file names containing embedded spaces. Say you were the unfortunate victim of a file called 2words.txt. If you tried to use this on the command line, word splitting would cause this to be treated as two separate arguments rather than the desired single arguments. By using double quotes, you can stop the word splitting and get the desired result. Further, you can even repair the damage. Now, we don't have to keep typing those pesky double quotes. Remember, parameter expansion, arithmetic expansion, and command substitution still take place within double quotes. We should take a moment to look at the effect of double quotes on command substitution. In our earlier example, we saw how word splitting appears to remove extra spaces in our text. By default, word splitting looks for the presence of spaces, tabs, and new lines, that is, line feed characters, and treats them as delimiters between words. This means that unquoted spaces, tabs, and new lines are not considered to be part of the text. They only serve as separators. Since they separate the words into different arguments, our example command line contains a command followed by 4 distinct arguments. If we add double quotes, word splitting is suppressed and the embedded spaces are not treated as delimiters. Rather, they become part of the argument. Once the double quotes are added, our command line contains a command followed by a single argument. The fact that new lines are considered delimiters by the word splitting mechanism causes an interesting, albeit subtle, effect on command substitution. Consider the following. In the first instance, the unquoted command substitution resulted in a command line containing 38 arguments. In the second, a command line with 1 argument that includes the embedded spaces and new lines. Single quotes. If you need to suppress all expansions, you use single quotes. Here is a comparison of unquoted, double quotes and single quotes. As you can see, with each succeeding level of quoting, more and more of the expansions are suppressed. More backslash tricks. If you look at the man pages for any program written by the GNU project, you will notice that in addition to command line options consisting of a dash and a single letter, there are also long option names that begin with 2 dashes. For example, the following are equivalent. Why do they support both? The short form is for lazy typist on the command line, and the long form is mostly for scripts, though some options may only be long form. I sometimes use obscure options, and I find the long form useful if I have to review a script again months after I wrote it. Seeing the long form helps me understand what the option does, saving me a trip to the man page. A little more typing now, a lot less work later. Laziness is maintained. As you might suspect, using the long form options can make a single command line very long. To combat this problem, you can use a backslash to get the shell to ignore a new line character like this. Using the backslash in this way allows us to embed new lines in a command. If you put a space after the backslash, the space will be ignored, not the new line. Backslashes are also used to insert special characters into a text. These are called backslash escape characters. Here are the common ones. Introduction to line editing. In this video, we are going to see about introduction to line editing. The following paragraphs describe the notation used to represent keystrokes. The text CK is read as Ctrl K and describes the character produced when the Ctrl key is depressed and the K key is struck. The text MK is read as Meta K and describes the character produced when the Meta key, that is, if you have one, is depressed and the K key is struck. If you do not have a Meta key, the identical keystroke can be generated by typing escape first and then typing K. Either process is known as metafying the K key. The text MCK is read as Meta Control K and describes the character produced by metafying CK. In addition, several keys have their own names. Specifically, del, escape, LFD, SPC, RET, and tab all stand for themselves when seen in the text or in an init file. Read line interaction. In this video, we are going to see about read line interaction. Often during an interactive section, you type in a long line of text only to notice that the first word on the line is misspelled. The readline library gives you a set of commands for manipulating that text as you type it in, allowing you to just fix your typo and not forcing you to retype the majority of the line. Using these editing commands, you move the cursor to the place that needs correction and delete or insert the text of the corrections. Then, when you are satisfied with the line, you simply press return. You do not have to be at the end of the line to press return. The entire line is accepted regardless of the location of the cursor within the line. Read line bare essentials. In order to enter characters into the line, simply type them. The typed character appears where the cursor was, and then the cursor moves one space to the right. If you mistype a character, you can use your erase character to back up and delete the mistyped character. Sometimes you may miss typing a character that you wanted to type and not notice your error until you have typed several other characters. In that case, you can type CB to move the cursor to the left and then correct your mistake. Afterwards, you can move the cursor to the right with CF. When you add text in the middle of a line, you will notice that characters to the right of the cursor are pushed over to make room for the text that you have inserted. Likewise, when you delete text behind the cursor, characters to the right of the cursor are pulled back to fill in the blank space created by the removal of the text. A list of the basic bare essentials for editing the text of an input line follows. CB, move back one character. CF, move forward one character. Del, delete the character to the left of the cursor. CD, delete the character underneath the cursor. Printing characters, insert the character into the line at the cursor. C, undo the last thing that you did. You can undo all the way back to an empty line. Read line movement commands. The above table describes the most basic possible keystrokes that you need in order to do editing of the input line. For your convenience, many other commands have been added in addition to CB, CF, CD, and del. Here are some commands for moving more rapidly about the line. CA, move to the start of the line. CE, move to the end of the line. MF, move forward a word. MB, move backward a word. CI, clear the screen, reprinting the current line at the top. Read line killing commands. Killing text means to delete the text from the line, but to save it away for later use, usually by yanking, that is, reinserting it back into the line. If the description for a command says that it kills text, then you can be sure that you can get the text back in a different or the same place later. Here is the list of commands for killing text. CK. Kill the text from the current cursor position to the end of the line. MD. Kill from the cursor to the end of the current word, or if between words, to the end of the next word. MDEL. Kill from the cursor that start of the previous word, or if between words, to the start of the previous word. CW. Kill from the cursor to the previous white space. This is different than MDEL because the word boundaries differ. CY. Yank the most recently killed text back into the buffer at the cursor. MY. Rotate the kill ring and yank the new top. You can only do this if the prior command is CY or MY. Read line arguments. You can pass numeric arguments to read line commands. Sometimes the argument acts as a repeat count, other times it is the sign of the argument that is significant. If you pass a negative argument to a command which normally acts in a forward direction, that command will act in a backward direction. For example, to kill text back to the start of the line, you might type MCK. The general way to pass numeric arguments to a command is to type meta digits before the command. If the first digit you type is a minus sign, then the sign of the argument will be negative. Bindable read line commands. In this video, we are going to see about bindable read line commands. Commands for moving. Beginning of line, that is CA, move to the start of the current line. End of line, that is CE, move to the end of the line. Forward char, that is CF, move forward a character. Backward char, that is CB, move back a character. Forward word, MF, move forward to the end of the next word. Words are composed of letters and digits. Backward word, that is MB, move back to the start of this or the previous word. Words are composed of letters and digits. Clear screen, that is CI, clear the screen and redraw the current line, leaving the current line at the top of the screen. Redraw current line, refresh the current line. By default, this is unbound. Commands for manipulating the history. Accept line, that is new line, return. Accept the line regardless of where the cursor is. If this line is not empty, add it to the history list according to the setting of the hist control variable. If this line was a history line, then restore the history line to its original state. Previous history, that is CP. Move up through the history list. Next history, CN. Move down through the history list. Beginning of history, M, lesser than. Move to the first line in the history. End of history, M, greater than. Move to the end of the input history, that is the line you are entering. Reverse search history, that is CR. Search backward starting at the current line and moving up through the history as necessary. This is an incremental search. Forward search history, that is CS. Search forward starting at the current line and moving down through the history as necessary. This is an incremental search. non-incremental reverse search history, that is MP. Search backward starting at the current line and moving up through the history as necessary using a non-incremental search for a string supplied by the user. Non-incremental forward search history, that is MN. Search forward starting at the current line and moving down through the history as necessary using a non-incremental search for a string supplied by the user. History search forward. Search forward through the history for the string of characters between the start of the current line and the current point. This is a non-incremental search. By default, this command is unbound. History search backward. Search backward through the history for the string of characters between the start of the current line and the current point. This is a non-incremental search. By default, this command is unbound. Commands for changing text. Delete char, that is CD. Delete the character under the cursor if the cursor is at the beginning of the line. There are no characters in the line and the last character typed was not CD. Then return EOF. Backward delete character, that is reboot. Delete the character behind the cursor. A numeric ARG says to kill the characters instead of deleting them. Quoted insert, that is CQCV. Add the next character that you have typed to the line verbatim. This is how to insert key sequences like CQ, for example. Tab insert, that is M-tab. Insert a tab character. Self insert, that is small a, small b, capital A, 1, exclamatory. Insert yourself. Transpose characters, that is CT. Draw the characters before the cursor forward over the character at the cursor, moving the cursor forward as well. If the insertion point is at the end of the line, then this transposes the last two characters of the line. Negative arguments don't work. Transpose words, that is empty. Drag the word behind the cursor past the word in front of the cursor, moving the cursor over that word as well. Uppercase word, that is MU. Uppercase the current or following word. When a negative argument, do the previous word but do not move the cursor. Downcase word, that is MI. Lowercase the current or following word with a negative argument. Do the previous word but do not move the cursor. Capitalize word, that is MC. Capitalize the current or following word with a negative argument. Do the previous word but do not move the cursor. Using GNOM Terminal. In this video, we are going to see about using GNOM Terminal. Similar to the MS-DOS prompt window, the GNOM Terminal provides a window in which you can type shell commands and view their output. To launch GNOM Terminal, right-click the desktop and select New Terminal from the pop-up menu. You can open multiple GNOM Terminal windows if you like. The GNOM Terminal application. The Edit gives current profile menu item lets you configure the operation of GNOM Terminal. For example, you may find that the default font is too large or too small for your liking. From the Editing Profile dialog box, select the General tab and disable the checkbox labeled Use same font as other applications. Click the name of the current font and a second dialog box pops up, from which you can select the font, font style and font size you prefer. To exit GNOME terminal, simply type exit on the command line and press enter. Alternatively, select close window from the file menu or simply type Ctrl D. The GNOME panel. Clicking on a launcher launches a predetermined application. You can easily add a launcher to the GNOME panel. To do so, right-click on the panel and select Add to Panel gives Launcher from the pop-up menu. The Create Launcher dialog box appears. You can specify a name for the launcher, a comment, and the command that GNOME executes to launch the application. GNOME automatically provides a default icon. If the program to be run is a text-based program, check the Run in Terminal checkbox. If an application is ready on the main menu, you can quickly create a launcher for it. Simply right-click on the application's menu item and select Add this launcher to panel or Add this applet as a launcher to panel from the pop-up menu. If your panel contains many launchers, it may become crowded and confusing. To remedy this, you can create one or more drawers like that shown in figure. Drawers act like menus. You click on a drawer to open it and view the launchers it contains. Clicking an open drawer closes it and hides its contents. To move a launcher into the drawer, click on the drawer to open it. Right-click on the launcher and select Move from the pop-up menu. Next, move the cursor over the open drawer and click the left mouse button to drop the launcher on the rectangular box above the drawer icon, not the drawer icon itself. If you add a launcher or drawer and later decide you don't want it, you can remove it from the panel. Simply right-click on the unwanted launcher and select Remove from Panel from the pop-up menu as shown in figure